Hello boys and girls. In this video we're going to talk about a coordinate geometry. Okay, so we see what this coordinate geometry is all about. Okay, so before we jump into this one, we need to understand what is a plane. Okay, so plane is something that is having one vertical line, a reference to vertical line, and a reference to horizontal line. Okay, so this horizontal line is called x-axis. X-axis, and the vertical line is called y-axis. Okay, x-axis and y-axis. Okay, see, okay, this x-axis on the right side can be divided equally and each division represents a unit distance. Okay, so this is 1 2 3 4 5 6 7 8 9 10. Okay, on the right side you're going to have 1 2 3 4 5 6. These are all positive numbers. Okay, so the place where both x and y axes are meeting is called origin. Okay, so where is the point? What is the point where both x and y axes are meeting? So this is the point. Okay, on x-axis this point is 0. If you go to the left of the x-axis, you will have all negative numbers. Those numbers again starts with, as you go to the left, it starts with -1, -2, -3, -4, -5, -6, -7, -8, and so on. Okay, and so on. There is no limit, like they'll extend on both sides, both on the right side and also on the left side, to an infinite distance. Okay, so there is no limit for it. But one thing is that when you're preparing a plane like this, when you're preparing x-axis and y-axis, we have to divide these parts equally. And the distance from here to here, here to here, here to here should be same. Okay, on the whiteboard you may not see it exactly equal, but if you take a graph paper, they'll be exactly the same. Like each square is 1 square centimeter. Okay, the length of the square, or the length of the square is 1 centimeter, and similarly on the see here you're going to have these kind of squares, right, in a graph paper. So each square represents a 1 square centimeter. Okay, so those lines, those grid lines on the graph paper are equally spaced, and the length of each division is 1 centimeter. Okay, okay, so on the x-axis we have divided like this. On the right side you will have all positive numbers, on the left side you have all negative numbers. Similarly on the y-axis, if you go to the top, you will have these positive numbers like this: 1 2 3 4 5 6 7 8, like this. Similarly, if you go down, you will have all negative numbers: -1, -2, -3, -4, -5, -6, -7, and -8, so on. Okay, again on the y-axis also there is no stop, like they will never end. They go on both sides, they extend on both sides, both on the right, both on the top and also on the bottom. They extend to an infinite level. Okay, so the entire reference to vertical line is called the y-axis. Similarly, the reference to horizontal line is called the x-axis. The place where they both meet is called origin. This point, the point where both x-axis and y-axis is called origin. Okay, so this entire plane is called, the entire plane, like this portion here, this portion here, this portion here, this portion here, is called a Cartesian plane. Cartesian plane. In this Cartesian plane or a coordinate plane, this is also called a coordinate plane or a Cartesian plane. In this Cartesian plane, you can represent a point, any point. For example, you pick up a point here. So this is one small point. Okay, point. You can represent any point with coordinates, x and y coordinates, or an ordered pair. Okay, x and y coordinates are an ordered pair. For example, if I want to represent this point, say for example I have given the name P to this point P. a P, A, B, C or anything can be. How do I represent this one? Okay, so if I tell P, does it strike to anybody that where that P point lies? No, right? P is the name, P is the letter that I gave to that point. Okay, nobody knows where that point is. If I say I have a point P in a Cartesian plane, instead of that, I need to give a coordinates to that point. That coordinates usually how they look like is 1, 2. Okay, I'll explain why I given this coordinates to this particular point P. The reason why I have given this point 1, 2, why I have given this coordinates 1, 2 for the point P is, see, look at here carefully. The point P, okay, this is an intersection of line. If you draw here and if you draw like this is a point where these two lines are meeting. These lines are coming, this line, the vertical line, if you see here, is coming from a place x is equal to 1, isn't it? X is equal to 1. Similarly, the point here, this line here is coming, is passing through a point 2 on the y-axis. So this is the point where both these lines are intersecting. Okay, so based on these lines, this coordinates for this point P are given. In other words, the coordinates for the point P are given. Write how far you are moving, right? Okay, if you are moving it to the right, you're going to have a positive number. If you go to the top, you're going to have a positive number. So how much I need to move to the right to arrive this point P from origin? On the right, I have to move to a distance 1 unit. How much do I have to move on to the up? I have to move 2 units on the up. Okay, the distance that I traveled to the right is represented by x-axis. Okay, the distance that I moved top is represented by y-axis. Because I am moving to the right, I got a positive number. Because I am moving top, I got a positive y coordinate. Okay, this 1, 2 are the coordinates of the point P. Coordinates are an ordered pair, both are same. Okay, both are same. So the point P having the coordinates 1, 2. 1, 2 is an ordered pair for a point P. Why is it called an ordered pair? Because they are arranged in a special order. The order is so important. 1, 2 is the point for a P. Okay, are the coordinates for a point P. You should not write the same point as 2, 1 because it is wrong. Because the 1 here, the first number here in coordinates represents the distance that you are moving on the x-axis. The second coordinate, the y coordinate, is also called a y coordinate, represents the distance that you are moving on the y-axis. If you are moving on the right, you will get a positive number. If you are moving on the left, you will get a negative number. Similarly, on the y-axis, if you move to the right top, you will get a positive number. If you move to the left, if you move to the down, you will get a negative number. I'm going to take another number. For example, here. So what is the coordinate for this point? So I'm going to name this point as a Q. Okay, because we already used P here, so I'm going to use this. I'm going to name this point as a Q. So what are the coordinates for this one? The first thing, to arrive at this point on x-axis, how much distance that you have to travel? Okay, on x-axis, how much distance you have to travel? So keep moving. So here is the place where you have to stop, because only if you go down here, you are going to reach this one. Okay, on x-axis, you move 3 units to the right. And on the y-axis, how much distance you have to come down? On y-axis, you have to come down 4 units. Because you are moving right, it's going to have a x-axis coordinate as 3. Since you are moving down, it's going to have a y coordinate in a negative number, and the distance that you move down is a 4 units. Since you move down, it's going to have a -4. Okay. So practice a couple of more points, but it's fairly easy to figure it out, like how to represent a point in a Cartesian plane or a coordinate plane. For example, I want to represent a point which is having a coordinate -2, -3. How do I do that? Because I have a -2 as an x coordinate, I need to move to the left. Because see here, x-axis. Where do I have a negative numbers? The first one represents x coordinate. Where do I have a negative numbers? So this is the reason, right? So the 2 units I have to move to the left and 3 units I have to move to the down, because on y-axis I have here from the bottom portion I have a negative numbers. So -2 and -3. So I moved -2, and if I move down here, so I'm going to have a point P. So this point, maybe you can say A. So this is the point A. Okay, a point is given and you identify the coordinates for it. Similarly, in coordinates are given and you spotted that point in the coordinate plane or a Cartesian plane. Okay, understand? Yeah, it's fairly simple. Similarly, let's take one more point. Say I have a point 5, 0. Okay, the point B. How do I spot this point? How do I identify this point in a coordinate plane? 5, 0. So it's going to have a positive x number, x coordinate. That's why I have to move to the right. So I moved right. That's fine. I moved up till here 5 units to the right because I have positive number. On the y-axis, I need to move 0. 0 units. 0 units. That means I should neither go up nor go down. So this is the place where I'm going to have a point B. Okay. So this point lies on the x-axis. Any point that lies on the x-axis will be having the y-coordinate as 0. Okay. So that's what we derived. You pick up any point. For example, see, -7, 0. -7, 0. How do I spot this point? How do I identify this point? So because I have x coordinate as a negative number, I need to move to the left. So I moved to the left 7 units. So I stopped here. On the y-axis, on the y coordinate, I have a 0. That's why I should not go up or I should not go down. Okay. So this is where I have to stop it. And this is that point. See here. This is also another point like this where y coordinate is 0. That is why this point also lies on the x-axis. Both B and C are lying on the x-axis. Okay. If you take some point on the y-axis, for example here, this is going to have x coordinate as 0. The reason is that x coordinate on x-axis, how much you have to move to reach to this point? You should not go anywhere. You just be at the center and keep going down and you will hit this point, -5. Okay, 0, -5. So what is that we have deduced here? So any point on the x-axis will be having a y coordinate as 0. Any point on the y-axis will be having an x coordinate as a 0. Okay, that's what we deduced. Alright? Yeah. And the point where both x and y-axis meets is called origin. What is the coordinates for that origin? This one. The coordinates of this origin is 0, 0. 0, 0. Okay. Alright. Now you understand what is x-axis, what is y-axis, what is a Cartesian plane. This whole thing is called a plane. On the plane, you can represent any point. For that point, we'll be having, points usually will be having a letter. Okay, a letter. P, A, B, C or anything. And that point can be represented by an ordered pair of two numbers. Why is it called ordered pair? Because that pair will obtain by keeping x coordinate and y coordinate, and they both are separated by comma and they are enclosed in a parenthesis. That is why they are called coordinates or an ordered pair. An ordered pair. Order is so important because the first one will represents a y-axis. Okay, the distance on the y-axis, and the second y coordinate will represent the distance on the y-axis. The first one represents the distance on the x-axis, and the second y coordinate represents the distance on the y-axis. If you move top on the y-axis, you will have a positive number. If you move down on the y-axis, you will have a negative number. Similarly, on x-axis, if you move to the right, you will have all positive numbers 1, 2, 3, 4, 5, 6, 7. Similarly, on x-axis, if you move to the left, you will have a negative numbers. All right. Okay, now you understand, given a point, you know how to spot it or how to identify the Cartesian plane, or if a point is given, you know how to identify the coordinates for that point. Both things you got to know. All right. Next thing. So this region where x and y are positive is called a first quadrant. First quadrant. Okay, before we do that, this entire Cartesian plane can be divided into four parts. Four quadrants. Okay, because we divided into four parts, each part is called a quadrant. Okay, quadrant is something like a 1/4. So this region is called the first quadrant, and this region is called the second quadrant, and this region is called third quadrant, and this region is fourth quadrant. On the first quadrant, so when you're naming those, when you give the numbers to those quadrants, you are moving on in anti-clockwise direction. You are moving in this way. The clock usually goes this way, but while you are giving the numbers to these quadrants, you are moving in anti-clockwise. This is first, second, third, fourth. Okay, so you moved in an anti-clockwise direction. Okay. Yeah, this is the first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. On first quadrant, every point will be having both positive numbers. Both will be having a positive numbers. X quadrant and Y quadrant will be having a positive numbers. Okay. On second quadrant, you will have, for example, I'm going to pick this point. What is this point? What are the coordinates for this point? -3, 4. Okay, so let's give some name to it. What name should we give? We give R. Okay, so the point on the this point lies in the second quadrant, and every point on the second quadrant will be having a negative x coordinate and a positive y coordinate. Okay, yeah, so here every point will be having both positive x and positive y coordinates, and here it will be having a negative x coordinate and a positive y coordinate. Similarly here, what is here? -2, -3. -2, -3. The point here in the third quadrant will be having both x and y negative numbers. Okay. Similarly here on the fourth quadrant, you will have a positive x and a negative y. Positive x coordinate and a negative y coordinate. Okay. Yeah, the first quadrant you will have a plus and plus. Both will be positive. In the second quadrant, you are going to have a minus and plus. X coordinate will be negative and y coordinate will be positive. In the third quadrant, you are going to have minus. Both will be having a negative quadrant. In the fourth quadrant, we have a positive and a negative. X coordinate will be positive number, y coordinate will be negative number. Okay. Yeah. So how about the points that lies on the axis? For example, the point B. What is point B? 5, 0. So which quadrant is this point lies on? Okay. This does not lie in any quadrant. This point lies on the x-axis. Similarly, the point here 0, -5 lies on y-axis. You cannot say this point lies in the fourth quadrant. You cannot say this point lies in the third quadrant, because this does not lie anywhere in any of the quadrants. Instead, this point lies on the y-axis only. Okay? Yeah. You understand, right? X-axis, y-axis, this is Cartesian plane, which can be divided into four parts. This is the first quadrant, second quadrant, third quadrant, fourth quadrant. First quadrant, both will be having a positive number. Second quadrant, a negative and a positive number. In the third quadrant, x coordinate and y coordinate will be negative numbers. In the fourth quadrant, you will have a positive x and a negative y. Okay? Yeah. And the place where both x-axis and y-axis meet is called origin. That origin is represented with the coordinates 0, 0. Okay? It's important. This is also called ordered pair because the order is so important. When you're representing it, you have to first represent the x coordinate and then the y coordinate. X coordinate represents on x axis how much you are moving. If you're moving to the right, you will have a positive number. If you move to the left of x axis, you will have a negative number. You will have a negative number like this. Similarly, on y axis, if you move to the right, you will have positive number. If you move to the down, you will have a negative number. For example, this one, minus 4. Alright. Now, we know what is a point, what is a Cartesian plane, what is the ordered pair, okay, what are the coordinates, and how to represent a point, and if a point is given, how to identify that point in a Cartesian plane. Okay, and the next thing is that, say for example, if 2 points are given in a Cartesian plane, how do you find out the distance? Okay, how do you find out the distance? For example, this is 1 point, 1, 2 is 1 point, and I'm going to have another point somewhere, say for example 3, 5, sorry, 4, 5. Okay, this point P and this point, say for example S, PS. Point P having the coordinates 1, 2. Point S is having coordinate 4, y. What is the distance between these 2 points? How do you find out? Okay, the distance obviously in units, like unit length, isn't it? How do you find it out? So the formula to find out the distance between the 2 points is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Distance between 2 points is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Because you are finding a square root, you will have both positive number and negative number. But you should only take a positive number because the distance between the 2 points will never be a negative number. Okay. Say for example this point here on the right side. For example, the same point is here, somewhere here. Will it be a negative distance? No, it will not be a negative distance because even here there is a distance between these 2 points. Okay. That is why you should only take a positive number. Let's see what is x2 and what is x1. Okay. For example, you pick up any point. It doesn't matter whether you take this as the first point, this as the second point, because if you measure from here to here or from here to here, you will get the same distance. The first point you consider as a x1, consider this one as a x1, y1. And the second point you consider this as x2, y2. x1, y1. Because this is the first point, I have given 1, x1, y1. Because I consider this as a second point, I given x2, y2. x2, y2. Okay. And now, to find out the distance, what is x2 here? 4. 4 minus 1 whole square plus what is y2? y2 is 5 minus 2 whole square. What is y1? 2. Okay, so you simplify this whole expression. 4 minus 1 is 3 square plus 5 minus 2 is 3 square. So, thereby you will get 9 plus 9, which is equal to square root of 18. So, somewhere here 4 point something. 4 point, you will get something. 4 point from 1 or 2, something like that. Okay. So, that is the distance between these 2 points. Okay. To verify this, you take one graph paper and identify 2 points. And using this method, you find out the distance between these 2 points. After that, take your scale, take your ruler and measure the distance. They both will match. Okay. x2 minus x1 whole square plus y2 minus y1 whole square. Okay. Even if you take this one as the first point, this one as the second point, you will get the same answer. For example, this one you consider this one as x1, this is y1, this one you consider this as x2, y2. Okay. In that case, what will happen? Instead of 4 minus 1, we have 1 minus 4. Okay. What do you get here? Minus 3 you will get here. When you square that one, when you square that minus 3 whole square, you will get 9 only. You will get 9 only. So whether you square 3 or whether you square minus 3, you will get 9 only. So that is why the distance will not change, whether you consider this as the first point or this as the first point. Okay, the distance is always the same. It's very important formula, when we're learning the coordinate geometry. Okay, say for example I have a point here, origin, which is 0, 0, and the other point is 1, 2. Other point is 1, 2. Say for example origin, I use this as O to represent, and this point is P, or I'll use this as the point, so we have some clarity. O to S, O to S. What is S coordinate? What are S coordinates? 4, 5. 4, 5. 4, 5. So to find out the distance between O and S, you can use this formula. There is no problem. Okay, this formula holds good wherever the point lies. Okay. Okay, but this is a special case where one of the point is at the origin. One of the point is at the origin. What do you get? You will have 0 here, you will have 0 here. You will have 0 here. The same formula is translated into, if you want to find out the distance from origin to any given point, the same formula, because we are going to keep here 0, x1 is 0, y1 is 0. The same formula is translated into square root of x square plus y square. Okay, distance from origin. Distance from origin, you're going to have, this is the formula. It came from this formula only. How we got this formula? Because we placed here as a 0, here as a 0. x1 is 0, y1 is 0. x2 minus 0, what is that? You will get x2 only. x2 square. What is x2? x2 is 4. What is y2? y2 is 5. Okay, so instead of x2 and y2, I just put a x and y. Because this is anyway 0, 0, and this is only one point having x and y coordinate. Okay, so that thing you simply substitute here. So if I substitute this one, 4 square plus 5 square. 4 square plus 5 square. So thereby you get 16 plus 25, isn't it? 16 plus 25, which is equal to how much? 11, 1, 41. 41. Yep. Yeah. So you get something like a 6 point something, 6.2 or 3 or something like that. Okay. So that is the distance between O and S. What is O? O is the origin. So to find out the distance between 2 points, this is the formula. To find out the distance of a point from origin, this is the formula. X square, square root of x square plus y square. Okay. Okay. If you don't want to remember both these formulas, just remember this one. Okay, this is good enough. Even if the one of the point is origin, keep here as 0, x1, y1 as a 0, 0. Okay, or x2, y2 as a 0. If you take this as the second point, you consider this as x2, y2. You place it here in this formula, you will get the same answer. Okay, so this is the distance between 2 points. Formula to find out the distance between 2 points is x2 minus x1 whole square plus y2 minus y1 whole square. Very, very important formula, and this came from a Pythagoras theorem, where the square of a hypotenuse is equal to square root of side square plus a side square. From there we derived this formula, because the distance between any 2 points will be considered as a hypotenuse for one right angle triangle. For example, if this is the line connecting these 2 points, the length or the distance between these 2 points is nothing but the length of the hypotenuse that is formed by a right angle triangle like this. Right angle triangle like this. Okay, so this is one side of a right angle, this is another side of a right angle, and this is the hypotenuse. Okay, where is the right angle? Here is the right angle. Okay, the side that is opposite to the right angle is called a hypotenuse. Okay, what is the Pythagoras theorem? Hypotenuse square, hyp square is equal to square root of is equal to side square plus side square. Side square plus side square. Okay, this is hyp square, hypotenuse square. If you want to find out the length of the hypotenuse, hyp is equal to square root of this square. If it goes to the other side, it becomes a square root. Square root of side square plus side square. Side square plus side square. How do you get a side? Length of each side. Length of each side. Say for example, length of this one. What is the length of this one? This length is 5 units. What is the length of this one? 4 units. The same thing you got here. Square root of 4 square plus 5 square. Okay. Not only here, this is the distance from origin, but even if you pick up some point here, we'll end up having the same formula. Okay, you'll get the same formula. Square root of x2 minus x1. x2 minus x1 will give the length of one side. I am squaring that one, that is side square. y2 minus y1 will give the length of another side. Another side. Okay, y2 minus y1 will give the length of another side. Alright, alright, yeah. So let's pick up. Okay, so I'm going to have 1 point, say 2 comma 2 comma minus 3. 1.2 comma minus 3. That is 1 point. And the other point is 5 comma minus 5. Sorry, 5 comma minus 5. So that's going to lie somewhere here. 5 comma minus 5. Okay. So this is the point. This is 2 comma minus 3. 1 point, and the other point is 5 comma minus 3. So what is the distance between these two? Again, the same formula you can apply. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. y2 minus y1 whole square. How can you form a right angle triangle here? This is a hypotenuse. You can draw something like this here. This is one side and this is another side. Okay. This is a right angle triangle. This is one side and this is another side. Height square is equal to side square. What is the length of this one? y2 x2 minus x1. The length here you will get 5 minus 2. That is the length of this one. Similarly, the length of this one is equal to minus 5 minus of minus 3. That is equal to 2 units. Say from here to here, what is the distance? You are already at the 3. Minus 3. You move down up till minus 5. What is the length of this? You get 2 only. What is the length of this one? You get 5 minus 2, which is 3. Let's do that one using the formula. What is the formula? What is the formula says? Our formula distance between 2 points is square root of x2 minus x1 whole square plus y2 minus y1 whole square. What is x2? So you consider this as the first point, x1, y1. Similarly, this one x2, y2. x1, y1. This is x2, comma y2. x2 minus x1, 5 minus 2. 5 minus 2 whole square plus y2 minus y1 minus 5 minus of minus 3, that is plus 3. We already have minus here. Because we have minus here, minus of that minus 3, we will get a plus 3 whole square. 5 minus 2 is 3 square. Similarly here minus 5 plus 3 is minus 2. When you square it, we get, okay, I am going to put minus 2 whole square. So you will get 9 plus 4, which is equal to square root of 13, which will be something like 3.23 or some units. Okay, so 3 units, 3 point some units, 3.2 or 3.3 units. Okay, so that is the distance between these 2 points. What is the first point? 2 minus 3. Second point is 5 minus 5. 5 comma minus 5. Or you can consider this as the first point. This can be a second point. Even in that case, we will get the same distance. Okay. Using the Pythagoras theorem, you can also do the same thing, and you will get the same answer. So for that, what is the side? Hyp square. Hyp square is the what is the hypotenuse? Hypotenuse is the distance between those 2 points. Hyp square is equal to side square plus side square. So if you want to know the hypotenuse, which is going to be square root of side square plus the side square. What is the length of one side? From here to here, see here 2 and here 5. What is the length? 3 units. Square root of 3 square. What is the length of this one? From 3 to minus 3 to minus 5. What is the length? 2 units. 2 square, which is equal to the length here. When you take a side, it's always a positive number. Okay, but you need to consider the absolute value from here to here. What is the distance? Here it is minus 3 and here it is minus 5. The distance is 2 units. Square root of 9 plus 4, which is equal to square root of 13. The same thing we got here. Okay? Yeah. The formula is this one, the distance between the 2 points, and this formula we actually derived from using this Pythagoras theorem, where the Pythagoras theorem states that half square is equal to side square plus side square. Based from there, we derived this formula. Okay, so we now found out the distance between the 2 points. One of the point can be origin. If one of the point is origin, the formula even becomes a simpler. That is square root of x square plus y square. Okay, but if you don't want to remember 2 formulas, just stick to this formula, and that gives the answer to find out the distance from any point to any point. From any point to any point. Okay? Yeah. One important thing when you're finding out the distance between the 2 points, if you say here x2 minus x1, here also should be y2 minus y1. That's very important aspect. Okay. You don't put x2 minus x1 here, and here you don't put a y. If you put x2 minus x1 here, you should put y2 minus y1 only here. You should not reverse it here. You should not put y1 minus y2. You will get an incorrect answer. Okay. That is why the order is important. If you consider this x1, y1, this is x2, y2. That is fine. Whether you consider this as the first point or second point, that is fine. Anything can be considered the first point. Other point can be considered as the second point. But when you are applying this formula, you are doing x2 minus x1 whole square. Here also it should be y2 minus y1. y2 minus y1 whole square. Okay. If you do x1 minus x2, here, you have to do y1 minus y2. Okay. 2 minus 1. 2 minus 1. If you do 1 minus 2, here also it should be 1 minus 2. y1 minus y2. Okay. Yeah, now we find out the distance between 2 points. The other important concept is to find out the middle point, given the 2 points are given. For example, I have a point here, 2, 4, and I have another point somewhere here, 8, 0. Because this is on the x-axis, I will have a y coordinate as 0. That is why I got a 8, 0. to find out the middle point. So what is the line connecting these 2 points? This is the line. I want to find out the middle line, middle point. Middle point is something that divides equally half. Okay, the distance from here to here should be the same. The formula to find out the middle point is or midpoint is x1 plus x2 by 2 comma y1 plus y2 by 2. x1 plus x2 by 2 comma y1 plus y2 by 2. What is x1? Again, you pick up any point as a first point and give the coordinates as x1, y1. 2, 4, consider this as an x1, y1. So 8, 0, consider this as x2, y2. x2 comma y2. Okay. So x1 corresponds to 2, y1 corresponds to 4. Similarly, x2 corresponds to 8, y2 corresponds to 0. Apply this formula. x1, what is x1? 2 plus 8 by 2 comma y1. What is y1? 4 plus 0 by 2. What do you get? 2 plus 8, that is 10. 10 by 2 comma 4 by 2. When you simplify this one, we get 5 comma 2. 5 comma 2 is a midpoint. Where is 5? Here is a 5. Where is 2? Somewhere here. So this is the midpoint. That makes sense, right? So the midpoint lies here only. That makes sense. Okay. So that is a formula to find out the midpoint. x1 plus x2 by 2 comma y1 plus y2 by 2. Okay. y1 plus y2 by 2. That is the midpoint. Again, it does not matter which one you consider this as the first point, which one you consider this as the second point. For the first point, you consider any point as the first point. But for the first point, you give the marking as x1, y1. For the second point, you compare the coordinates as, you consider the coordinates as x2, y2. And substitute those coordinates in this formula and you will get the midpoint. Okay. So the midpoint and the given 2 points are on the same line. Those three points are collinear points. Collinear points means points that lies on the same line are called collinear points. Okay. This midpoint always lies on the line that is connecting those two given points. Okay. So that is the middle point or a midpoint formula. x1 plus x2 by 2 comma y1 plus y2 by 2. Okay. There is also one more concept to learn here in this basic coordinate geometry is, for example, some point here, a point here, we don't know what that point is, dividing the line connecting these 2 points in the ratio of 1:2. Okay, this side is 1 part and this side is 2 part. It's important. This side is 1 part and this side is 2 parts. So, in other words, this point is dividing this line connecting these 2 points in the ratio of 1:2. Okay, and the 1 part is in this side and the 2 parts are on this side. What is that point? There is a formula for it. That one, consider this as a L, consider this as an M. The formula for that is, okay, so consider this point as D. The coordinates for point D, L into x2 plus m into x1. LM is the ratio in which it is dividing m into x1 by L plus m, comma, for y coordinates L into y2 plus m into y1, my1 by L plus m. What do you get? You will get a point. What is L and M? L and M is the ratio in which this line is divided into. We have L parts here and M parts here on the other side. To find out this point D that divides in the ratio L is to M, here is the formula. L into x2, M plus M into x1. See here, see the sequence. L, I consider this as x1, y1. I consider the other point as x2, y2. Okay, I consider the other point as x2, y2. So I assume that the point D, which is cutting this line in the ratio of L is to M. In such a case, to find out the coordinates for D, this is the formula. L is to x2 plus L into x2 plus M into x1 by L plus M, comma, for y coordinate L into y2 plus M into y1. See, I am going the other way. This part is L parts, this part is M parts. To find out this point, L into x2 plus M into x1. Similarly, for y coordinate, L into y2 plus M into y1 plus M into y1 by L plus M. L plus M here and here both are same. Okay. So let's do it. What is L here? 1. What is M here? 2. 1 into x2 is 8 plus what is M? M is 2. 2 into x1. What is x1? 2 by L plus M. What is L plus M? 3, comma, L into y2. What is L? 1 into y2. 1 into y2 is 0 plus M. What is M? 2 into 4. 2 into 4 by L plus M, which is 3. Now you simplify this one. 1 into 8, 8 plus 4. That is 12 by 3, comma, 8. 1 zeros are 0 plus 2 fours are 8. 8 by 3. So you will get 4, comma, 8 by 3 is something like 2.6. 4, comma, 2.6 is that point. 4, comma, 2.6. What is this point? Whose coordinates are 4, comma, 2.6? The coordinates for D are 4, comma, 2.6. Where is D? D is here. What is D doing? D is cutting the line connecting this point and this point in the ratio of 1 is to 2. 1 is to 2. 1 parts this side and 2 parts this side. Okay. To find out the coordinates for D, this is the formula. You need to know the ratio in which it is cutting. And in this case, it is important what is x1, y1, what is x2, y2. You need to do it this way, like the parts here, you have to represent it in a line. In a line, you have to draw some rough line. And you need to know which side is L parts, which side is M parts. Or which side is what ratio and which side and the other side what is the ratio. I mean, like how many parts on one side, how many parts on the other side. Again, this into this plus this into this by L plus M. That is one coordinate, like x coordinate. Similarly, L into y2. So this into this one plus this into this one by L plus M. Okay. This is all will give you x coordinate. This whole thing will give you y coordinate. When you keep these together with a comma separation and put them in a brackets, you will get a coordinate for a point D, which is cutting the line in the ratio of L is to M. Okay. Finding out the point is fine, but sometimes you're also asked the point D is given and you're asked to find out what is the ratio that it will cut in. Okay, that is bit tricky, bit complex, because you need to find out L and Y, L and M, two variables you need to find out. We'll get two linear equations, and you have to solve that linear equation to get L and M. Because this is not known, this is not known, this is not known, this is not known, this is not known. Okay, and this is also not known, this is also not known. Because L and M are not known. In this case, L and M are known. That is why we simply substitute in the formula and we found out the coordinates for point A. In other case, this point is given, this point is given, and the point D is also given, and you are asked to find out L and M. In such case, you will get two linear equations. That is a bit tricky. You get two linear equations and you have to solve those two linear equations to find out L and M. Okay. Let us stop this one. This is all about the theory part of a coordinate geometry, basic coordinate geometry. The main aspects are what is a Cartesian plane, how to identify a point in a Cartesian plane, what is x-axis, what is y-axis, what is origin, what is an ordered pair, and the quadrants, the first quadrant, second quadrant, third quadrant, fourth quadrant, and the distance between the 2 points. The distance between 2 points, that is very, very important formula, and that is derived from a Pythagoras theorem, whose formula between 2 points is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, and the other aspect is the middle point or a midpoint. Given 2 points, what is the midpoint? Midpoint is something that divides equally. Given the line connecting those 2 points equally. The formula for that one is x1 plus x2 by 2, comma y1 plus y2 by 2. Okay. And the third aspect is to find the point that is dividing the given 2 points, or that is dividing the line connecting the given 2 points in the ratio of L is to M. In such case, the formula is L into x2 plus M into x1 by L plus M, comma L into y2 plus M into y1 by L plus M. Simplify this one and you will get a point. That point is connecting, is dividing the line that is connecting these 2 points in the ratio of L is to M. L parts this side and M parts this side. Okay, yeah. We will leave it there, and this is all about the theory of coordinate geometry, and we'll meet up again and we'll pick some problems and we'll try to solve them in some other session. Thank you.